2012, number 2. This is the calculator problem, and it looks like it is a vector problem. So a particle is moving along a curve so that its position at time t is this, and at time t equals 2, the particle is at 1, 5. And we know the derivatives. We know the velocities, in other words. That's the x velocity and the y velocity. Part A. Is the horizontal movement of the particle to the left or the right at time 2? Explain your answer. Well, that's just a matter of if this is positive or negative. So let's go ahead and, since I'm going to be doing stuff with these, maybe I'll just put them in y equals, so then I can call them up as y1 and y2. You don't have to do that, but you could. So let's make this one x plus 2 divided by e to the x. Right? And then I'll make this one sine of x squared. Make sure you double the parentheses on that, right? So you're squaring the whole thing. That's what that means. Okay, so I want to know for the first one, let's see what times. It looks like we're looking at, this is time 2. We never get more than time 4. So why don't we go ahead and take a look at them. Well, actually, I'll go back. There's more than one way to do this, as you know, with the calculator. But I just want to plug 2 into that one. So one way to do that is you can go, variables, y1, and then put a 2 there, I think. I think that works, yeah. And then you plug 2 into that. So it's like doing f of something. Let me just make sure that that does that, and then we will all have learned something about our calculator. So if I plug 2 into this, that's like doing the square root of 4 divided by e to the 4th. Oops, what did I do? Oh, I didn't need that. Oh, so that's not right. So I don't know what that was doing, so never mind that. Maybe you have to put it in parentheses or something. I don't know. So if you plug 2 into this, you get, so dx dt at t equals 2 is 0.073, which is greater than 0. So the particle's moving to the right. Right? Right is positive. It's moving right. Sorry about all that calculator nonsense there. Explain your answer. Our answer is that the derivative is positive, so that's fine. Oops, we're not done with A yet. Find the slope of the path of the particle at time 2. So that would be, it would be dy dt over dx dt at time 2. So that is this, the sine of 2 squared divided by 4 over, I'm not going to use my rounded decimal version, but whatever, you could probably do that and get away with it. That'll give me a little bit more accurate. So that is 11.286. 11.286. And you should write out something like that to indicate what you're doing, because you get points for that. Find the x-coordinate of the particle's position at time 4. Well, if I'm actually trying to find x-coordinates, I must be taking an antiderivative, right, of dx dt. And if I want it at time 4, the time that I know about is time 2. So that's what I know about, and that's what I want. And that antiderivative is going to give me the position at 4 minus the position at 2. And I know the position, the x position is at 2 is 1. So this is equal to 1. So that means, so 4 is equal to my integral plus 1, adding that to the other side. So let's do that. I can do this, math 9 fn int of y1 comma x comma 2 comma 4, because y1 was my dx dt, and then I want to add 1 to that. That gives me 1.253. All right. C, find the speed of the particle at time 4, and find the acceleration vector of the particle at time 4. Well, the speed is the square root of dx dt squared plus dy dt squared, evaluated at t equals 4. That's how we do that, right? So, what's the easiest way to enter that into the calculator? I guess this is certainly a chance to make some mistakes. So I need to do, let's try to get the whole thing in. We'll do the square root of, that's my big set of parentheses. And then in another set of parentheses, I need, when I plug 4 into this, that's going to give me the square root of 6 over e to the 6. So I need the square root of 6 over e to the 6. That closes that set of parentheses, and then I'm going to square that whole thing. Don't close again, because if you close again, then you're closing the square root sign, and I do not want to close the square root sign yet, right? Plus another set of parentheses, the sine of 4 and normally it's getting squared anyway, so when I square that, it's actually going to be to the 4th power, right? And then I can end that whole big square root sign, and that's it, right? So I think the speed is 0.573. I should really have a copy of the rubric here so I can check these, but we'll hope that I didn't make a mistake. And then the acceleration vector is equal to the second derivative of each, evaluated at t equals 4. So I'm going to use n-deriv to do that, and I'll just write them down as I go. So let's see. We have math 8, n-deriv. I'll do the y first. Oops, what happened there? Went variables, y variables, y1, comma x, comma 4. That'll give me my derivative. That's negative 0.041. Notice I'm doing 3 decimals, not 3 significant figures, 3 decimal places. And then I want to do the same thing again, except this time I want to do it with y2. That's 0.989. There's the acceleration vector. Okay, last part. Find the distance traveled by the particle from time 2 to time 4. Well, it's the integral of the speed, right? The integral of the absolute value of velocity. Of course, the absolute value of velocity is speed, right? So I'm going to write it out, just because I might get some points for that. The integral from 2 to 4 of this plus this. And then we'll do it with the calculator. So I have math 9. We want the integral, the square root of y1. This is the advantage of entering them in earlier. y1 squared plus y2 squared. Oops. Oh yeah, I do want to close that, sorry. Comma x, comma 2, comma 4. Come on, calculator, there we go. 0.651. All right, that was pretty serious calculator work there. But that's all tricks that we know how to do, and it's all stuff we've done fairly recently, so you should knock that one out of the park, I hope. Likely that you will see something like that.